Hello everyone, welcome to my channel Physics with Bhatt. To learn concepts of physics, subscribe this channel and press the bell icon button to get notified for every new video lecture. Hello everyone, this is Bhatt once again with you. Today I brought one another important topic in the series of video lecture for the chapter atom. This is quite interesting and this is about the trajectory of alpha particle scattered in the Rutherford's experiment. So we will discuss about the scattering of alpha particle, how these alpha particles are deviating and which kind of path is followed. The trajectory of alpha particles scattered is parabolic in shape. So this is very clear that the deviated alpha particle will follow the parabolic path. To understand this, we just take the help of diagram. This is the shape of atom and this is nucleus with the charge Ze and it is lying on the center of the atom. Now we take one by one the different alpha particles passing through the atom at different distances. So just see, this is the first one which has passed far away from the nucleus and it is deviated from its original path when it experiences the repulsive force of nucleus. This is the reference line which is indicating the deviation of the alpha particle. This is second alpha particle we have taken. It is little closer to the nucleus and this is also deviated from its original path as it passes just close to the nucleus. This is the reference line indicating the angle of deviation. This is another alpha particle which passed further closer to the nucleus and it is deviated more in comparison to the previous two. This is the reference line indicating the deviation. If the alpha particle is just falling in front of the nucleus, then it is reverted back along the same path in opposite direction. So we have seen the angle of scattering is different according to the distance of alpha particle from the nucleus. Those alpha particles which are near to the nucleus, they are scattered with greater angle in comparison to those which are away from the nucleus. These distances which we were talking are denoted by small b and this small b is known as impact parameter, and the angle with which these alpha particles are scattered is known as angle of scattering. So we can see very clearly from this diagram, if b is large, then angle of scattering is small. If b is small, then angle of scattering is large. So how to define this distance b? That you will see in the text. The perpendicular distance of initial velocity vector from the center of nucleus is termed as impact parameter. With decrease of impact parameter, the angle of scattering increases. That is also very clear from the diagram. For small values of b, the angle of scattering is comparatively large. One more distance is marked here and it is for the particle which is falling the nucleus for b is equal to 0. This particular distance is denoted by small d and this small d is known as distance of closest approach. So if impact parameter is 0, then alpha particle is scattered with maximum angle 180 degree in opposite direction, and this particular distance up to which the particle approaches close is known as distance to the closest approach. So in this section we discussed about the importance of impact parameter and what is impact parameter, that is also clear from the diagram. In the remaining section of this video lecture, we will talk about distance to the closest approach. That I just told you that it is the minimum distance of alpha particle which is just interacting with nucleus and falling in front of the nucleus. Alpha particle undergoing head-on collision with zero impact parameter approaches close to the nucleus comes momentarily to rest and retraces its path in opposite direction. That I told you right now. The particle which is moving towards the nucleus with zero impact parameter is scattered with angle of scattering 180 degree, and the distance which is minimum distance between the alpha particle and nucleus is known as distance of closest approach, denoted by small d. So, to find the expression for this distance of closest approach is very easy. We will follow the law of conservation of energy for the purpose. At this point, the energy of alpha particle is due to potential energy only. Why it is so? Because at this point the alpha particle comes momentarily to rest and then reverted back in opposite direction. So, total initial energy would be equal to total final energy. This is we are taking from the law of conservation of energy. Initial energy is because of kinetic energy only, and final energy at this point is because of potential energy only. Kinetic energy is denoted by capital K, and potential energy is given by K Q1 Q2 upon D. Here small k is Coulomb's constant, Q1 is charge of alpha particle, Q2 is charge of nucleus, and this D is distance of the closest approach, and on left side this capital K is kinetic energy. So, if you want to have the expression for small d, it would be D is equal to K ZE into 2E upon capital K. Here ZE is the charge of nucleus and 2 is the charge of alpha particle. So, D is equal to twice K ZE square upon capital K. So, this is the formula for distance of closest approach, and it is given by D is equal to twice K ZE square upon capital K. Capital K is kinetic energy. Here Z is the atomic number of the gold, because in the experiment we have taken gold foil. So, this is all about the concept of trajectory of alpha particle in the scattering experiment, and we came to know about the two important terms, impact parameter and distance of the closest approach. I hope this video would help you in understanding the concept of these two important terms, impact parameter and distance of the closest approach. Thanks for watching this video. We will meet very soon in the next video lecture. Till then, keep watching, keep learning.